Okay, so we're going to go over homework B. So make sure you have your list here of your activity series. Probably also need your periodic table with you. So let's just get right into it. So part one is a mixture of single replacement reactions and double replacement reactions. So let's start. We have barium nitrate plus potassium sulfate. By the way, before we even get into this, if you're not good on your naming, just go back, pause this, watch some naming videos, do what you have to do to get right with naming, because if you don't know naming, no use in even trying these. Anyway, we're looking for is this single or double, so I have 4 species here. It's going to be a double. Now before I go and proceed with it, I'm going to check my activity series. And what we're looking for is aqueous and aqueous before we even know to start it. So barium nitrate is aqueous. Potassium sulfate is aqueous. So we can proceed. So what I'm going to do is switch the cations. So I'm going to get barium sulfate plus potassium nitrate. And again, with this, you have to know how to balance them out. I'll just run through it since this is the first example. I know barium's going to be matching with sulfate. So sulfate is SO4 2-, barium is Ba2+. So you can see it's going to be a 1-to-1. So we just write BaSO4 for potassium and nitrate. Potassium is always going to come first because that's the positive part, the cation. Potassium has a charge of plus. Nitrate, NO3-. Again, it's going to be 1-to-1. So I just write KNO3. Okay, so before I'm done, I need to check if this is actually going to be a legitimate reaction. So what I'm looking for is one of these to be aqueous and one of these to be either solid, liquid, or gas. Now, you can tell by this, the vast majority of the time, you're going to look for solid as you're insoluble. So barium sulfate is solid. Potassium nitrate is aqueous. And the more you do, you might catch on to certain things. For example, nitrate is aqueous all down the line. If you see nitrate, aqueous. For example, ammonium, aqueous all down the line. Anyway, we have aqueous, aqueous, solid, aqueous. We know the reaction will take place, so now we're going to balance it. So 1 barium, 2 nitrates. I need 2 nitrates, but that gives me 2 potassiums, which I'm good with. So this is correct, so that's number 1. Number 2, CaCO3 plus NaCl. Sounds familiar because this is what we formed in class. So for this, it's going to be a double replacement reaction because I have calcium chloride, carbonate plus sodium chloride, so 4 species. I'm going to check my chart. Calcium carbonate, solid. It is not aqueous, so we can just stop right here. No reaction. If you were there in class the day I took the sodium carbonate and mixed it with the calcium chloride, this is what we created, and the fact that it didn't spontaneously go back into those 2 things, I mean, that tells us there's going to be no reaction. So that's number 2. Number 3, BaO, barium oxide, plus potassium. So for this one, we're going to have a single replacement reaction. I have one thing by itself, plus 2 species here. So the single thing is always going to try to bump one of the 2 out of the compound. So since potassium always forms K+, barium always forms Ba2+, I'm not interested in the number, but I am interested in the charge. Since this forms a positive cation, this forms a positive cation, positives always try to bump positives. So what I need to ask myself, is potassium strong enough to bump barium? So for this, we're going to use the front of our activity series. We're going to find potassium, we're going to find barium, whichever one is higher is stronger. So here's potassium, here's barium. yes, this reaction will take place. So I'm going to have a reaction between potassium and barium. So it's going to be sorry, misspoke there. It's going to be potassium and oxygen. So it's going to be K2O. And barium gets bumped by itself. And now we balance. 2 potassiums, and we're balanced. So this is what you're looking at for number 3. Number 4. Silver nitrate plus sodium bromide. Double replacement reaction. So the first thing we check, are these going to be soluble? So you check here, you notice that that's going to be aqueous, which I know, by the way, always aqueous. NaBr, so that's sodium bromide, aqueous. So far, so good. So I'm going to switch up the cations now. So I'll do silver bromide, and I'll do sodium nitrate. And now I check those solubilities. So silver bromide, solid, looks good. I'm hoping for aqueous, and by the way, nitrogen or nitrate always aqueous. AQ. So this will go through. Okay, and now to balance it, I just check, and in fact, it's already balanced. So this is number 4. Number 5. FeCl3 iron 3 chloride plus KOH potassium hydroxide. So we have a double replacement reaction. So I'm going to check my solubilities. By the way, it's important that you know this is iron 3, not iron 2, because different listings. So iron 3 chloride gives us aqueous. KOH, so potassium hydroxide, aqueous. By the way, potassium is another one where you see it all the way across. So aqueous. So we know the reaction is going to take place. Let me go ahead and switch my products here. So since this iron was a 3+ before, it has to remain a 3+ after. So you don't preserve these numbers, like the 1s and the 3s, but you do have to maintain this charge. So I'm going to need an iron with a 3+ to react with my hydroxide. E here. So like that. So it's going to be iron 3 hydroxide plus potassium chloride, KCl. And now I'm going to check my chart. So I believe that's going to be aqueous. Iron 3 hydroxide. I was wrong. Solid. Potassium chloride. Aqueous. So therefore this is a legitimate reaction. And now we balance. So let's see. I have 3 chlorines, so I need 3 chlorines. Now my potassiums, 3 potassiums, 3 hydroxide, 3 hydroxide. Correct. All right, number 6. NH4 3PO4 ammonium phosphate plus K2S potassium sulfate. Double replacement reaction. So ammonium and phosphate is going to be aqueous. Potassium sulfate. Sulfide is aqueous. This is going to yield NH4 2S, ammonium sulfide plus potassium phosphate. Alright, so I believe this is going to be aqueous. I think all of them are. Yep, aqueous. Potassium phosphate. Potassium It's going to be aqueous. So, aqueous, 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 aqueous. There's nothing going to form here. You're just going to get this soup of 4 ions floating around. So, no reaction. Number 7. Copper plus FeNO3, 2. So that's going to be copper plus iron 2 nitrate. So this is a single replacement reaction. We have one thing trying to bump its way into 2. So the copper is going to try to bump the iron. So we need to look at the front here. Can copper bump iron? No, it can't. Copper's way down here. Iron's above it. No reaction. Okay, number 8. CuNO3, 2 plus NaOH yields. So this one is double. 1, 2, 3, 4. Okay, so the first thing we check is the reaction going to take place. So copper nitrate, I know that this is going to be aqueous. Nitrate, always aqueous. NaOH, I believe, is also aqueous. Hydroxide, sodium. Yep. So the reaction will, in essence, begin. So I'm going to write, now remember, this is a copper with a 2 plus, so I need to preserve that 2 plus. So I'm going to get CuOH2 plus NaNO3. Okay, let me check this. So it's going to be copper 2 hydroxide is a solid. NaNO3, I already know, is going to be aqueous. So this reaction will take place. Okay, so now I need to go back and balance. Let's see, I have 2 nitrates there, so I need 2 nitrates. This gives me 2 sodiums, 2 sodiums, 2 hydroxides, 2 hydroxides. It's balanced. All right, last one. Bromide, or I should say bromine, plus NH4I, ammonium iodide. Single replacement reaction. I have one thing trying to bump its way into 2. So the bromine is going to try to bump the iodine here because they're both the anions. So is bromine strong enough to bump iodine? I'm going to check my chart. Yes, it is. Bromine is above iodine. So we're going to get NH4Br plus I2. Remember the Brinkelhoff, or what I call the green elements up on my periodic table. Whenever I bump iodine out, it's not going to be just plus I, it's going to be plus I2. So going back and balancing, I need 2 iodines, and now I need 2 ammoniums, 2 bromines. We're good. Okay, so that is the first part, single and double. Part 2. For this one, I'm looking to balance them. I'm looking to identify the type. All right, so number 1 says copper 2 plus sulfur. So for this, I just have one thing plus another thing. So in essence, I have A plus B. Only thing this could possibly be is synthesis. And since the charge is given, I know I have copper with a charge of 2 plus, sulfur with a charge of 2 minus, CuS, copper 2 sulfide. Already balanced. Number 2, aqueous silver nitrate. AgNO3, aqueous, is added to aqueous iron 2 bromide, FeBr2, aqueous. So this is going to be double displacement because we have 1, 2, 3, 4 species. I need to look and see if the reaction is going to take place. So I already know this is aqueous because nitrate, and iron 2 bromide is aqueous. So we're good so far. So switching up the ions, I get silver bromide, and I get Remember, this iron has to remain iron 2. So iron 2 nitrate, which is going to be FeNO3 2. And I'm going to look these up now. So silver bromide is a solid. Iron 2 nitrate. Remember, you can look all the way across everything with nitrate, aqueous. So this is going to take place. And now I just need to balance it. So I have 2 bromines, 2 silvers, 2 nitrates, 2 nitrates. And it's balanced. Number 3. Hydrogen peroxide, aka dihydrogen dioxide, decomposes. H2O2. This one was straight out of the PowerPoint notes. When this decomposes, it splits into H2O plus O2. Just something you have to remember. And we need to balance it out by putting a 2 here and a 2 there, and we're good. Benzene combusts C6H6 plus O2. So in a combustion reaction, we're always going to form CO2 plus H2O, unless it tells you something otherwise. If I tell you it has incomplete combustion, I'll probably tell you what the products are going to be. But if it just says combust, this is the general formula. So it's about balancing. Now a little trick that I've kind of picked up, I'm not sure if it works 100% of the time, but I'll sort of share it here. I believe that if this is even, we don't need a 2 there. If it's odd, we need a 2, but let's try it out. So I'm going to put a 3 here to balance my hydrogens. I tend to balance hydrogens first. Yeah, I was wrong. I'm going to need another number. So by balancing my hydrogens, I have an even number here, even number there, but if I look at my oxygens, I'm going to have 3 plus an even number here. So that's not going to work. I'm going to need to double this. So let me put a 6 here and a 2 here. So my hydrogens, I have 12 and 12. 12 carbons, I'll do 12 carbons. And now let me add up my oxygens. So I have 12 times 2, that's 24 oxygens, plus 6, so that's 30, so I need 15 here. In fact, I think the rule is just going to work with the hydrogen. I believe if that is odd, scratch that whole rule. Just work it out. So 2, 15, 12, 6. Alright, number 6. Chromium with a charge of 4. Plus O2. So you might think this is combustion because it's plus O2. However, it doesn't involve a hydrocarbon. This is just chromium. It's not any form of C and H. So the only thing this can be is synthesis. A plus B yields AB. So if I'm going to mix chromium with a charge of 4 plus and oxygen, which has a charge of 2 minus, you can either crisscross rule and simplify, or you can just recognize that I need 2 oxygens to balance this, CrO2. And it's balanced. Number 7, aqueous sodium hydroxide. So that's going to be NaOH, aqueous. Is added to aqueous potassium acetate. C2H3O2 aqueous. So, double replacement reaction. Sodium hydroxide. Oh, I already have this written here. Aqueous, aqueous. So I need to write my products. So it's going to be NaC2H3O2. Let me check that one. Sodium acetate, aqueous, plus OH is going to mix with my K, so KOH, which I am 99% sure is also aqueous. Let me double check. Potassium hydroxide, aqueous. So I have aqueous, 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 aqueous. No reaction, because nothing's going to form. It's just going to keep floating around. No reaction. Okay, number 8. Liquid iodine. Iodine is a Brinkelhoff. I2 is added to aqueous aluminum bromide. AlBr3. Single replacement reaction. The iodine is going to try to bump the bromine. So, can iodine bump bromine? No, it cannot. No reaction. Iodine is below bromine. No reaction. Number 9. Whoosh bottle demonstration, which was with the big sort of Poland Spring jug. Rubbing alcohol combusts. C3H8O plus O2. Since it combusts and I don't tell you anything special, CO2 plus H2O. So this one's just about balancing. Now we haven't really dealt with the extra O here, so we're just going to try to work this out. Let me start by matching my hydrogens. 4 is going to match my H's. Let me match my carbons, so 3. This will work actually. Maybe? No, I don't think so. Because look, I have 6 O's plus 4, so 10. I could do a 5 here, but that's not going to work. So when in doubt, double everything. 8, 6, 2. Let's see if this works out. So carbons, I have 6 and 6. Hydrogens, I have 16, 16. Let me look at my O's. Over here, I have 6 times 2, so I have 12. I have 8, so I have 20. This will work. Here, I have 2, so I need to get the rest, so I need 18 more, so 9. 2, 9, 6, 8. All right. Silver oxide decomposes. Ag2O. It's only going to split into 2 possible things. Ag and O2. Remember, anytime a metal is by itself, we just list it as the metal, just Ag. And since O is a Brinkelhoff, goes paired. So this one's just about balancing. So I need 2 of these. Actually, I'm going to need more because I can't do anything here. So I need 2 oxygens, 2 oxygens. There we go. 4 silver, 2 oxygen. Number 11. Piece of magnesium ribbon, pure Mg, is dropped into a beaker of aqueous manganese 2 sulfite. Mg is dropped into manganese 2 sulfite. Wow, we haven't worked at that in a while. SO3. And I know that this is a formula because sulfite has a charge of 2 minus, manganese 2 is 2 plus. Single replacement reaction. So something's going to try to bump something. Magnesium is going to try to bump manganese. Can it do so? I'm guessing yes it can. Uh-oh. Oh, there it is. Magnesium can bump manganese, yes. So this will go through. So we're going to get MgSO3 plus Mn. And just real quickly, I did this in my head, but what you need to know is you're going to have magnesium reacting with sulfite, so it's Mg2 plus, and sulfite is SO3 2 minus. Crisscross rule is going to be 2, 2, simplify it down to 1, 1, or you could just look at this and say, oh, it's 1 to 1. And as for this manganese, even though it has a charge of 2 plus, we don't write anything. We're not going to say plus Mn2, or we're not going to say plus Mn2 plus. Once it gets kicked out, it just becomes neutral. So just plus Mn. Steel wool burns to form iron 3 oxide. We've done this one plenty of times. Steel wool is iron. Burns plus O2. to form iron 3 oxide, Fe2O3. We don't have that quickly. Iron 3 oxide, so it's an Fe with a charge of 3 plus. Oxide is O with a charge of 2 minus. Fe2O3. Okay? So all we have to do is balance. So I'm going to need a 2, a 3, and a 4. Okay, so that is homework B. For the quiz, you're going to see a lot of problems like you have on the back of this. Okay?